Good morning, Year 4, and welcome to your maths lesson for Monday, the 25th of January. The good news is we're moving on this week to a new topic. I'm just going to share my screen now. And this week we're going to be learning all about area. So a quick warm-up. I say a quick warm-up, it's quite a long warm-up actually today, but the lesson's quite quick. So swings and roundabouts. So you can pause the video here and have a go at these column subtractions. Don't forget that some of them may need to exchange, but they don't all need to exchange. So just pause here and have a go at those, and we'll come back together in a minute and go through them. Okay, so let's move on and I will show you the answers. I'm not going to go through all of these individually because it will take a really long time. So I'll just talk you through the first one to remind you, and then you can check your answers. I tried to show you the exchanging as well so that you can see where you went wrong if you've not got the correct answer. So we did 3, take away 6, and obviously if we've got 3, then we can't take away 6 from that and still end up in positive numbers. So we need to exchange, we need to go next door, and we need to exchange one of those. So we cross out the 4, put a 3, and put the 10 into the ones column. And now we've given ourselves 13. So 13 take away 6, 7. And then we can do 3 take away 2, that's fine, it's 1. And then 2 take away 1 is 1, and 5 take away 2 is 3. So the answer is 3,117. And you can have a little check through those, pause it if you need to, and check the rest of your answers there. Okay, so moving on to our area today. The area of this shape here is 12 squares, okay? So just have a little look at it. And I just want you to think about what is area. If you had to describe to somebody what area means, what would you say? Okay. So area is the amount of space inside a shape. So when we were doing perimeter, and we said that perimeter, we were talking about round the rim, around the edge of the shape. But that when we're talking about area, that's the amount of space inside a shape. So if you think about the playground, it's about how much space you would have to run around on the playground, in the middle of the playground, okay? Not the distance walking around the edge, because that's perimeter. Okay, so here the area of the shape is 12 squares because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares. So have a look at these two shapes. Which of these shapes covers the largest area? So if the area is the amount of space inside a shape, then this one, the blue one, has the largest area. So if you were thinking about on a little plan, if this was a playground and this was a playground, then the children playing on the blue section of the playground would have a bigger play area than the children playing on the purple section of the playground. And maybe one day there'll be a day where we don't have to have sections on the playground again and we can all mix in together. Okay, moving on. This is a sticky note, okay, and what I would like you to do is to estimate how many sticky notes you need to make these shapes. I'm getting a cup of coffee given to me. It's good when your children get big enough to make you hot drinks. Thank you, Thomas. So have a look at the sticky note. Estimate how many sticky notes, how many of these sticky notes do you think you would need to make the shapes below? Okay, so if I show you the first one, this shape here, this rectangle would fit 1, 2 sticky notes on it, wouldn't it? So estimate how many sticky notes you would need for those. Which shape do you predict would have the largest area, and which would have the smallest area? So remember, the area is the amount of space inside a shape. So you can pause it here, predict which one you think will have the largest area and the smallest, and we'll have a little check in a second. Okay, so we already said that this one was 2, didn't we? It was 2 squares. So let's stick a 2 on that to remind us. Now let's have a little look at the next one. We've got 1 square, 2 squares, 3 squares, 4 squares. So that one, 4 sticky notes, has an area of 4 sticky notes. And then this one here has an area of 1, 2, 3 sticky notes. Pop a 3 on there. And then the next one has an area of 1, 2, 3 sticky notes also. So that's got the same area as the sage green one. And then this last one, let's try this one. It has an area of 1, 2, 3, 4 sticky notes. Don't usually measure area in sticky notes. We'll get to what we do measure them in just a second. Okay, so in answer to our questions, which shape do you predict would have the largest area? If you predicted one of those shapes would have the largest area, then you were correct. And which would have the smallest is obviously this one, because it's only got 2 sticky notes. Okay, moving on. We can calculate the area of shapes by counting the squares inside them. So sometimes they help you, and squares are drawn onto your shapes. So if each square has 1 centimetre sides, then we measure the area in square centimetres, okay? And we write centimetre squared or square centimetres like this. We have cm, which stands for centimetres, and then the little 2 up in the air like that stands for squared, okay? So if we have a little look here, we've got, so we're imagining that each edge of the square is 1 centimetre, like that, okay? So they're centimetre squares. So we've got 1 centimetre square, 2 centimetres square, 3 square centimetres, and 4 square centimetres. So the answer to that one, the area is 4 centimetres squared, which sounds a little bit more technical and mathsy than sticky notes. So you can pause the video here and have a go at working out the area for the rest of the shapes, and we will come back together in just a second and go through those. Okay, so let's have a look at these together. Going to count them. So each square, as we said, is 1 centimetre square. So we've got 1, 2, 3, 4 again. So that the area of that one is 4 centimetres squared again. And then over here, this one's a little bit more tricky because it's only half the square is shaded if you look. But if we put 2 of those halves together, then that will make a whole one, won't it? So if I turned that one around and slotted it up there, that would make a whole one. And then if I turn that one around and slotted it up there, it would make a whole one. So these are all halves, and 4 halves make 2. So there's 2 whole ones there, because 2 halves make a whole. So that one has an area of 2 centimetres squared. Then this one, 1, 2, 3, 4, 5. This is 5 centimetres squared there. I would recommend when you're counting, these are quite straightforward ones, but if you were doing this on paper, I would be telling you that it's a good idea to do like a little dot or something on each one that you've counted, so you don't end up counting them all at once. 1, 2, 3, 4, 5, 6, 7. So that one is 7 centimetres squared. And then the last one, 1, 2, 3, 4, 5, 6 centimetres squared. So hopefully you managed to count those. I should have probably said at the start, but you don't need to draw out all these shapes, okay? You just need to write down the letter of the shape. So you could write E equals 7, F equals 6, C equals 2, like that. Okay, so just always assume that's what I want you to do on these. You should never be having to draw out all the shapes unless I particularly tell you to. Okay, this one. Do these shapes have the same area? So pause the video, have a little think. If you've got someone to talk to them. If not, talk to yourself. Do you think these shapes have the same area, and why or why not? Okay, so pause and have a little think. Okay, so some people may have thought, yes, these do have the same area because there are 4 squares here and there are 4 squares here, but these squares are not the same size, are they? So if I took one of these squares and I put it on there, can you see that that square is quite a lot smaller than that square? Now, you might be thinking, but there's four squares there and there's 4 squares there. But if we think about these as playgrounds again, or bars of chocolate, whichever you prefer, if you were going out onto the playground, which one would you want to be able to play on? This one is clearly bigger, isn't it? You can see it's bigger. Or if this was 4 squares of chocolate and this was 4 squares of chocolate or something else that you like to eat, I know which one I'd pick off the plate. If that was a brownie, a chocolate brownie, and that was a chocolate brownie, they've both got 4 pieces. I know which one I'd be picking up, and it definitely wouldn't be that one. So this one, they actually has a larger area, okay, even though they've both got 4 squares, because on these, each side was 1 centimetre, okay, but on these, the differences, the sides are different, okay. This is about 1 centimetre, and this is about 1.5 centimetres, okay, so it has a different area. Okay, so I'm glad we've mentioned the size of squares, because on these, your hinge question is which shape is the odd one out. Now, these are not, oddly, the squares are not all the same size, but I want you to imagine that the squares are all the same size, okay? So imagine that they are all 1 centimetre square squares. And can you please pause and work out which one is the odd one out and why? Okay, so let's have a look. The first thing I'm going to do to try and work out which one's the odd one out is I'm going to count the squares and work out the area of each shape, because it's obviously a bit of a hint that we're doing area, so it's going to be something to do with area, isn't it? So A has 1, 2, 3, 4, 5, 6, 7, 8. It has an area of 8. And then I'm going to write centimetre, and then the 2 has to be up there a little bit, okay, up in the air, so it's 8 centimetres square. Then this one has, B has an area, imagining that they're 1 centimetre square again, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that one has an area of 9 centimetre, I have to do this one separately, squared, up there, okay. And then this one here, 1, 2, 3, 4, 5, 6, 7, 8 centimetres square. Because I'm imagining that they're all centimetres if they were drawn properly. There we go. So now when I look at them, it's handy to write the areas next to them as well so that I don't forget. I can see that one's got an area of 8 centimetres squared, and so does that one, and that one's got 9. So I'm going to suggest that B is the odd one out because it has a larger area than A and C. Okay, and A and C both have an area of 8. So moving on. For your silver task today, you have to complete the number sentences for each shape. So the area of the shape is however many squares. It doesn't say centimetre squares, it just says however many squares, so you can just count those. Then, for each of them, obviously, here is a patchwork quilt. It is made from different coloured squares. Find the area of each colour. So you're looking at what's the area of the purple squares, what's the area of the yellow squares, the green and the orange. Okay, so you can pause it here and have a go at silver, and I will move on to gold in just a second. Okay, so silver's all done, and let's move on to gold. So here it's just like the hinge question really, which is the odd one out. So you have to look at each of these and look at which one's the odd one out and tell me why. And obviously it's always to do with area, because that's what our lesson is about today. So you don't need to draw the shape, you just write 3A and then equals A, B or C, whichever one you choose is the odd one out, because that's explaining. Then 3B, A, B or C is the odd one out because, and then 9A, blah, blah, 9B, like that, okay? And then we will know which one you mean without having to draw it all out. And then platinum, Teddy and Eva are measuring the area of the same rectangle. Teddy uses circles to find the area. Eva uses squares to find the area. Whose method do you think is more reliable, and explain why? Okay, so that's an interesting one. Just have a little look at those two. Which one do you think is the most reliable? If we were trying to say find the area of these rectangles. The next one. 2 children have measured the top of their desk. They use different size squares. Dora says the area of the tabletop is 6 squares. Alex says the area of the tabletop is 9 squares. Who has used the largest squares, and how do you know? Okay, you might want to, for that one, actually measure the top of a table, a smallish table, with some cut out squares and see what happens when you change the size of the squares. Okay. Or you can measure even, it doesn't have to be a table, it could be a piece of paper or something. So you might want to make something a bit practical to help you with that, okay? So maybe get something that you're going to measure the size of, a small coffee table or something, measure the area of it with smaller squares, and then measure it with bigger squares, and that will help you to work out the answer to this question, okay? And then you are all done for your Monday maths lesson, and I will see you again tomorrow for some more area on Tuesday's math lesson. Okay, bye-bye.